Hello Legacy students! Today we're going to start our last unit of the year. Yay! Today we're going to look at graphing exponential growth and decay models. You're going to want to have those 4 graphs I provided you, a calculator, and then a pen or a pencil as well. So, I got a question first. Would you rather have $10,000 given to you every day for the next 30 days, or would you want a penny today, but I'll double it every day for the next 30 days? Now you're probably going to say, well, option A, Marsh, I don't want a penny today, and it's going to double. But actually, guys, you're going to get a lot more money using option B. Doesn't look like it, but you actually will. By the 10th day already, I already am going to be having $1,000. So ultimately, guys, you're actually going to find that option B is going to go faster and grow a lot faster than the $10,000 given to you every day. Doesn't sound like it, but it actually will. So here's what we're actually looking at. Growth and decay. Things that grow and decline at certain rates. Now, your bank account, aka your savings account, that is exponential growth. Population, usually that's growth or decline. And then radiation or half-lives and stuff like that you talk about in chemistry, that's decline. The depreciation on your car, that's going down. And then also carbon dating, which is what they use to figure out how old a fossil or a mummy is. That is also decline. That's what exponential growth and decay is used for in the real world. So we're going to look at 2 different kinds of graphs today. What's known as a exponential growth graph, so that looks like something that goes up, and then a decay graph, which looks like it's going down, kind of like a slide. Those are the 2 kinds of graphs we're going to look at today. So, some stuff you're going to want to be able to do today. We're going to want to be able to graph exponential growth and decay functions. We're going to want to identify the domain and range, and then we're also going to talk about asymptotes and be able to identify them on our graphs. So, the model that we're going to basically be using. All of our graphs are going to look something like y equals a times b to the x. And you're going to be able to tell if it's a growth or a decay graph based on what your b value is. If your b is greater than 1, that is a growth function. Then b will be called your growth factor. If b is between 0 and 1, that's a decay function. Thus, my decay factor, it would look like it's going to go as a slide, okay, for my b. So, let's actually try a couple of examples here. So, I have the graph f of x equals 3 times 2 to the x. So, the very first thing, guys, I'm going to look at what's known as the parent graph of this function, which is basically the graph that has no transformations done. So, my parent graph would be y equals 2 to the x. Some key points on this graph, if I look and see if I would actually use a table for this, one number I can always plug in is 0, and that would be 1. And then another key point I could do would be 1, and I would get 2. If I plug in 1, I would get 2, right? Plug in 2, I'll get 4. Plug in a -1, I'll get 1/2. So I'll get a graph, ultimately, it's going to look something like that, right? Because 2, 4 would be the dot right here, stuff like that. So now, how are we going to take care of that 3? So that's basically my graph, but with a vertical stretch of 3 now. So, let's move up our graph 3 units. So instead of being at 1, it's going to actually be up at 3. So 1, 2, 3, right there. This one, we're going to move up 3 as well from it. Or actually, notice how normally it would have just been up 1 over 1. So now from this dot, it's actually going to be up 3 over 1, because that's my vertical stretch. So I'm going to go up 1, 2, 3 over 1. This now would be my graph. Now notice, guys, how I kind of made it curve here. that is what your graphs are always going to do. They're not going to cross a certain area. And that's called what's known as an asymptote. And we'll talk about that on our next slide. So what about my domain and my range? So we'll leave asymptote for a little bit here, but domain, notice guys, I'm getting all my x's, positive and negative, so my domain would be negative infinity to infinity. My range, notice guys, I'm not crossing 0, not going down to the negatives. So my range would be from 0, but not including 0, notice there's those parentheses there, to, whoops, infinity. So from 0 to infinity would be my range. Now, let's talk about what's an asymptote. An asymptote is a line that the line graph approaches more and more closely but never truly touches. Basically, it hugs it but no touchy. No kisses. Just kind of hugs. Never really actually crosses over, never truly touches it. So in particular, this graph would have an asymptote of y equals 3. Because notice guys, it just kind of gets very, very close to that line, but it never truly crosses it. So if I look back at our last one, my asymptote would be at right here. Right there. Which would be y equals 0. Your asymptote is always going to be an equation. Usually it will be y equals some number. Let's look at another one. So I got this parent graph first of 3 to the x. Notice guys, it is 3 to the x because I don't want all this transformation stuff going on too. So my key points would be the points 0, 1, so if I plug in 0, I'll get 1 back out, and 1, 3. So as I plug in 1, I'll get 3 to the first, which is just 3. So I'll graph those 0, 1, 1, 3, 1, 2. So this would be 3 to the x. It would be a graph that looks something like this, right? Now, what are we going to do? This is, I gotta move my translated. So guys, the exponent part, that means you're going to move left or right, and since it's a negative, you're actually gonna move right. And then the outside part is the down 5 part. So with these two dots, I'm going to move right 2 and down 5. So I'm going to go right 2, 1, 2, down 5. 1, 2, 3, 4, 5. Then I'm going to go right 2, 1, 2, down 5. 1, 2, 3, 4, 5. So my graph is going to do something like, whoopsies, that. Notice guys, I'm not crossing -5. That would be what our asymptote would be. So if I put it in here with my, let's do some green, my asymptote would be right here at -5. Normally, before you move, your asymptote would be at 0, but since I went down 5, that's actually where your asymptote is now going to be. So if you have a vertical shift at all, that's where your asymptote's going to be. So my asymptote would be y equals -5. Notice guys though, my domain is still -infinity to infinity. I have not changed at all in that. And then my range looks like it's from -5 to +infinity, but not including -5. So it'd be -5 to infinity for my range. Let's try this one. So -4 times the quantity of 2 to the x plus 1 plus 3. So my parent graph is 2 to the x. So some key points I have on him, 0, 1, and 1, 2. So let's go ahead and graph that. 0, 1, 1, 2. That way it makes it easier for me to be able to figure it out here. There we go. So now I need to do some translations. So very first thing I got to do is my vertical stretch of 4. So normally I would have been at 1 for my vertical stretch. So my vertical stretch right here tells me to go 4. So instead of being at 1 here, I'm going to go 1, 2, 3, 4. That's going to be that dot. Then this dot, I'm going to go from this dot, I get to go up 4 over 1. Because normally I went up 1 over 1, but since my stretch is 4, I'm going to go up 1, 2, 3, 4 over 1. Right there. So now my graph is this. Whoops, nope. Didn't slope it right because I haven't shifted up or down at all, so it's just going to go like this. Okay. Now, I got to flip because of this negative. I got to flip it. So now instead of being up here, it's actually going to be down here at -4, and it looks like 1, 8. So about right here. So now my graph's actually going to do this. Okay. Now, last thing's got to go left 1, up 3. So I'm going to change my color here so I can be able to see what's going on. So left 1 on this dot, left 1, up 3. 1, 2, 3. That's my dot right there. And then left 1, up 3. 1, 2, 3. There's my dot. So my actual graph, guys, at the end of this will be the following graph. It'll be like this. And like this. Because I do know my asymptote will be here at 3 because that is my vertical shift up. Like that. So my asymptote is at y equals 3. So that's the graph I know I cannot cross. My domain will be from -infinity to infinity. And my range looks like I'm covering from -infinity to a +3. So -infinity to a 3. So my asymptote will always be my vertical change that I have used. Let's try the last one here. Notice, guys, this is a decay graph because my b value, my 1/5, is a fraction. So my key points on this graph is going to be 0, 1, and 1, 1/5, right? So 0, 1, 1, and 1/5. So I'm going to have a graph that looks something like this. Like that. Okay, now let's do our transformations. It looks like we just need to go up 1. So with each of these graphs, each of these dots, excuse me, I gotta go up 1. So I'm gonna go, let's go green, up 1 here, up 1 there. So my new, oh yeah, it's 1/5. There we go. My new graph is gonna do something like this. Whoops, that's a little off on that side, but that's okay. So my asymptotes would be y equals 1 because I cannot cross over the 1 value. My domain is from -infinity to infinity, and my range would be from 1 to infinity. And that's the end of this video. See you later, Sabers.